Good afternoon, all of you. So, in the last class, we have seen Maxwell's equations. Okay, and I think what is that? Last one, that is existence of electromagnetic waves. Yes, no. These two things we have finished. So, see here next point. Maxwell's equations. Next point you write. Along with the Lorentz force. Lorentz force you know already. Yes, no. That is Q A bar plus Q P bar cross B bar. So Maxwell's equations along with Lorentz force give complete description of all magnetic interactions. Yes, right? So now, first of all, let's see what is meant by electromagnetic waves. Okay, what is meant by electromagnetic waves? So see here. What is the definition of electromagnetic wave? Yes. So the oscillating so what are the electromagnetic waves? See, the oscillating electric and magnetic fields regenerate each other and propagate through space as a waves is called electromagnetic waves. Okay, if we will draw the diagram of this, or else I will tell on next page. Okay, How is the nature of these electromagnetic waves? Okay, I will draw on the next page. So first, what is the source of these electromagnetic waves? Means how or who will produce or something like that. Source of this electromagnetic waves, or how we can say how electromagnetic waves are getting produced. So see here, EM waves are produced by number one, that is by accelerated charge. First thing is what? Accelerated charge produces electromagnetic waves. Yes, in starting of the electrostatic chapter, I told you the charge which is at rest, it will give electric field. Yes, charge is in motion, gives you magnetic field. But if suppose something or charge is accelerated, then it will give electric field, magnetic field, as well as radiate some amount of energy. Understand? And that is what this electromagnetic wave. Okay. So the first one is what? Accelerated charge. Next one, oscillating dipole. Oscillating dipole will also produce electromagnetic waves. And third one, charge in circular motion. Charge in circular motion. Okay. So this is what the, or due to which the electromagnetic waves are getting reduced. So they are asking you sometimes how electromagnetic waves are getting produced. So you should be able to tell all this. Okay. So note down fast. So let's move ahead. And now, nature of electromagnetic wave. I'm drawing the diagram, just see. This is x-axis, this is y, and this is z. And this wave is propagating like this. Okay. This is what electric field along the x-axis. You can see here. This I'm just representing. This is what electric field vector, like this. and then along this. Along this you have magnetic field like this. So this is what E, electric field vector, and this is what magnetic field vector. If we will see here in the diagram, you see this electric field. So E bar along x-axis, E bar along x-axis, B bar along y-axis. Yes, and E bar cross B bar is nothing but what? Direction of propagation. Okay, direction of propagation, and that is along z-axis. Okay, clear? And this wave is nothing but what? Linearly polarized electromagnetic wave no, this is what nature. Okay, and this is what diagram I have shown, how it is propagating through medium also, or particularly the nature, particularly nature of electromagnetic waves, how it is, means electric field is how in this mixture, then magnetic field is how direction of propagation is in its direction, like that. A linearly polarized electromagnetic wave propagating in the z direction with the oscillating electric field EF, that is E bar along x direction or x axis, oscillating magnetic field, that is B bar along y direction or y axis. Okay, so this is what the electromagnetic waves. Now we will see the equations of this. First you note down this, draw the diagram. Okay, so let's move ahead. Now how to represent this wave? To see here, representation. Now this E bar, that is electric field vector, is equal to Ex I cap, because it is propagating along x axis. So it is equal to E naught sine kz minus omega t, and it is along I cap, where E naught is what? Amplitude. Okay, and k is what? Wave vector. Already we know k is equal to what? 2 pi by lambda, and omega is what? 2 pi f. Yes, angular frequency. Okay, this already we know. In wave chapter also we have learned this k and omega. Now this is b bar. B bar is equal to what? By j cap, and this is equal to b naught sine kz minus omega t, and this is along j cap. Okay, this is along j cap. Okay, now here also b naught is amplitude, and remaining thing already I have mentioned above. Okay, right, so that is amplitude. And now here velocity or speed of EM waves is c, which is equal to omega by k. Same like in waves, how we got phi is equal to omega by k. Same here also, c is equal to omega by k. Okay, and also this c is equal to 1 by under root mu naught epsilon naught. Okay, and from this I can write c is equal to omega by k. Yes, no? So from this, can I write like this? Omega is equal to c into k. Omega is equal to 2 pi f, which is equal to c into 2 pi by lambda. This 2 pi and this 2 pi will get cancelled. And here also c is equal to f lambda is true. Okay, c is equal to f lambda is also true. Okay, so these are the some or few formulas which we have to keep it in mind. Also, one more, that is even c is equal to e by b, which is also equal to e naught by b naught. So these are the formula of velocity of electromagnetic waves in terms of amplitude of electric field wave and magnetic field wave. Okay, and always this c is equal to 1 by under root mu naught epsilon naught which is equal to speed of light, that is 3 into 10 to the power 8 meter per second. Okay. In a medium, C in medium, that is velocity of electromagnetic wave in medium is equal to 1 by under root mu into epsilon. Mu is what? Permeability in medium. This is permittivity in medium. Yes. So this I will write on next page. Okay. So I need some space. So that's why you just note down till here. Okay. Note down till here. Any doubt you can ask. Finished everyone. So this is what C is equal to 1 by under root mu naught epsilon naught. This is in vacuum. Okay. Yes, no. Now let's see in medium what happens. In medium, C in medium is equal to 1 by under root mu epsilon. Now already we know mu r is equal to mu divided by mu naught, and it is called relative permeability. Yes, no? What is this? Relative permeability. So that implies mu is equal to mu r into mu naught. Yes. Similarly, epsilon r is equal to epsilon by epsilon naught, and this is what? Relative permittivity. Yes, what is this? Relative permittivity. And this permeability and permittivity already you know. So epsilon is equal to epsilon r into epsilon naught. So therefore, C in medium is equal to 1 divided by under root mu r mu naught into epsilon r epsilon naught. Okay. So this is equal to, I can write like this, 1 by under root mu naught epsilon naught into mu r epsilon r, and that's why C in medium is equal to C divided by under root of mu r epsilon r. Okay, right. Okay, clear. So this is what the velocity in medium, either this formula or even this formula, anything you can use. Now if suppose I will divide this, so this is what vacuum no. So C divided by C medium, because we know refractive index formula we have. Refractive index I am denoting with n now. Okay, why? Because mu I have denoted with this permeability. So although in ray optics we have denoted with mu, now I am denoting with n. Okay, so this is what ray, what is formula? Velocity of light in medium, or velocity of light in vacuum to the velocity of light in medium. Yes, no? C by V. Yes, this is what our original formula. So here what I want this C by C medium I want. So can I write like this, C by C medium, which is equal to, or just C by C medium, that is refractive index, and therefore I am writing here N is equal to C by C medium, which is equal to under root of mu r epsilon r. Just transfer here this term here and this term here, you will get this, and that is what your refractive index formula. Okay, so now you can note down this formula also. Do it fast. Okay, note down. Go ahead. Let's move ahead. Now, even though wavelengths are different for different wavelengths of EM waves, velocity is same. Okay, in a vacuum. Okay, this is very important, right? Because here velocity is going to be constant, that is in vacuum. Now the pointing vector S bar is equal to E bar cross H bar. H already we have learned in moving charges, okay, or in magnetism and matter, that is magnetizing field vector. So this H bar we know what is that, P bar by mu naught, and therefore S bar is equal to E bar cross B bar by mu naught, and this pointing vector, it represents it represents it represents the direction of energy. It represents the direction of energy flow per unit area per second along the direction of wave propagation. Along the direction of wave propagation. Its unit is watt per meter square. Yes. Okay. This is what your pointing vector. Okay. Note down this.